Hello everyone, welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how to determine whether or not a molecule is polar. And so I'm going to go over a couple of examples and explain how you can tell whether a molecule is polar. So the first thing you need to do is write the Lewis dot structure. Once you get the Lewis dot structure, then you need to use Vesper theory to figure out what the molecular shape of what the molecular shape is. And then that should help you be able to figure out if it's polar or not. So the first thing you need to determine once you've got the shape, once you've got the Lewis dot structure, is this does it have any lone pairs? Does it have any different atoms? Things like that. So let's look at our first problem. So the first problem here is our ammonia, NH3, and here's the Lewis dot structure for ammonia. So for ammonia, you see that there are 4 electron groups. So 4 electron groups tells you that for the electron geometry, it's tetrahedral. But we have 1 lone pair. So that's going to tell us that instead of the molecular geometry being the same as the electron geometry, tetrahedral, it's going to be different. And so in this case, when you have 3 bonding groups and 1 lone pair, that means that the shape is going to be geometrical electron, So the electron geometry is going to be trigonal pyramidal. Okay, so if you remember what that looks like where you have the electron lone pair on the top, and then the other 3 atoms are being pushed down. And so now you have to look at what your molecule looks like. So one of the things you want to consider is, are all the atoms the same or different? So, and then, well, before that, you would have to figure out, are the bonds polar? And so you look at the difference in electronegativity of the atoms, and you would say, okay, if it's greater than 0.5 or greater, then you know you have polar bonds. So we have polar bonds here, so that's good. If there's no polar bonds in your molecule, then there's no polarity in the whole molecule. So that's the first thing. So if there's polarity in the bonds, it could be polar, but maybe not. So once you checked off polarity in the bond, and then you got to go to the next thing, which is, do you have asymmetry in your molecule? Meaning that, is there a way that you can divide the molecule such that one side is going to be more polar than the other side, or if you have a difference in on what side? Okay, so with regard to ammonia, since the 3 hydrogens are going to be pushed downward and you've got the lone pair on top, you're going to have an asymmetry in your molecule. One of the other things you want to look at in the molecule is, like, let's say if you can't imagine what it looks like in your head, or if you have trouble visualizing something like that, then you could just look at do I have lone pairs here? If you do have a lone pair, then that's probably most likely going to be it's going to be a polar situation. But not necessarily. The other thing you have to look at is, are the atoms all the same, right? If all the atoms are the same, it could be non-polar. But if you have lone pairs there, then that's usually going to tend towards the polarity of the molecule, because, again, the lone pairs are your negative electrons. They're going to be on one side, and they're pushing the atoms away. Okay, so in this case, you do have symmetry. You do have the polarity of the bonds. The bonds are being pointed downwards, so you're going to have a partial positive side, and then the nitrogen is more electronegative, so that means it's going to have more electron density around it. So that means that this side is going to be negative, this side is going to be positive. So you've got a polar molecule. For CH4, here's the Lewis dot structure for CH4. Excuse me. So you'll notice here that you've got 4 bonds, no lone pairs, so this is tetrahedral. And so when you're looking at this molecule here, you're going to first question is, are the bonds polar? And so you have, you're looking at the electronegativity difference between carbon and fluorine. Fluorine is your most electronegative atom. So there's going to be a larger difference between carbon and fluorine. So there's a large difference there. So each bond is polar. So you've got polarity in the bond. Great. So you check that off. We're still not done yet, because even though you have polar bonds, you could still have a non-polar molecule if there is no symmetry in the molecule. So if all the bonds are the same and there's no lone pairs, then it's definitely going to be a non-polar molecule. So one of the things you look for is lone pairs. So if there are no lone pairs in your molecule, that's probably going to be non-polar. The other thing you want to look at is, are all the atoms the same, or all the bonds the same? Notice that they're all single bonds. Notice that I have all single bonded fluorines to my carbon. So the bonds are the same, the atoms that are bonded to the carbon are all the same, there's no lone pairs, so this is going to be a symmetrical molecule, there's no asymmetry, so therefore all of the polarity in the bonds are going to cancel out, so the molecule is non-polar. So whenever you're also thinking about looking at the polarity and the difference in the bonds, make sure you keep in mind that there could be resonance, right? So if you do have a double bond, right, that double bond could be averaged over the other bonds, as we've seen in other molecules in other videos that I have done. So for this molecule, this would be a non-polar molecule. So what's going to be a dead giveaway for something to be non-polar? Usually it's going to have lone pairs on the central atom. And there's going to be probably a difference in bonds, a difference in the atoms bonded to your central atom, right? Because different atoms have different electronegativities, and therefore they're either going to be partial negative or partial positive. So you're looking for any form of asymmetry in your molecule that allows for a separation of charge, a positive side and a negative side. I hope this was helpful. Thanks for joining me. If you like this video, share this video with your friends. Hit the like button, hit the notification bell so you'll be notified for any videos I put out. Make sure you subscribe to the channel and make a comment in the comment section and let me know what you think, if you have any questions you want me to answer. Thanks for joining me, and I'll see you next time.